Hi there, this is Mr. Wolf. Today we're doing geometry benchmark number 19. I can identify and apply transformations. So yes, we're traveling back in time because we skipped this benchmark initially. Now we're going to go back and pick it up. Just a couple reminders. Make sure that you take at least a page of notes, preferably more, and bring those to class to show that you did watch the video. And if you have any questions, you can post them on the YouTube page, or you can post them on my website. This benchmark actually has a lot of content, so I'm sure that you'll be able to take more than one page. Okay, so let's get started here. First, we are talking about transformations, so let's understand what they are. A transformation changes the position of a shape on a coordinate plane. What that really means is that a shape is moving from one place to another. These are the four types of transformations that we'll cover: a reflection, translation, rotation, and a dilation. And you'll notice dilation is italicized because it's a little different than the others, and we'll talk about that. First, let's get a definition down. An isometry is a transformation that does not change the shape or size of a figure. So those first three, reflections, translations, rotations, those are all isometries because they don't change the shape or size of the figure. Dilations are not isometries because they do change the size. Sometimes we'll call isometries congruence transformations, or more often rigid motions. Okay, rigid because they don't change size. So that's the difference between those three here and a dilation. So let's start with looking at what each one is. The red is going to be our initial shape. We'll call that our pre-image, the red one. So a reflection would be right here and right here, the lowercase r. So what we did was reflect this red triangle over the y-axis, and we got this figure. We reflected the red triangle over the x-axis, and we got this figure. Okay, so those are reflections. A translation or a slide would be an example of this figure. We took the red pre-image and we slid it over a couple spaces, and it looks like 4 over and 2 up. So that's a translation. A rotation is located down here. We took the red triangle and we rotated it all the way around 180 degrees, and it ends up here on the opposite side and upside down. And last, the bigger triangle is a dilation. That means we enlarge or we make smaller this original image. In this case, we enlarge the pre-image. So let's talk about these in details. First, if you're going to rename any transformation, normally when we name a figure, for example, right here, our square figure here, that is our pre-image, so we just call it A, B, C, D. And this figure over here is our post-image. And so we put those little tick marks there to indicate that it's a transformed shape, just so we know what those little marks right there mean. First up are reflections, and you've got several notes to take here. I'm going to scroll down so you can copy these. Pause right now, and you need to copy all of this. Yes, I realize it's a lot, but there is a lot to this benchmark. So copy down this table. Okay, now that you've got that copied down, you also need to add down here for point reflections. Okay, so up here we've got line reflections, and down here you have point reflections. We can reflect figures over a line, or we can reflect figures over a point. Okay? So let's take a look and decide if these transformations are reflections. Okay? In figure A, is this red figure, a reflection of this? You decide. Is this a reflection of that? You decide. And then here I'll show you the answers. The answer is no and yes. This is not a flipped image. It's actually just a translation. It's a slide. But this over here is a reflection. It is the same image, just flipped across the line. Same thing here. Which one is a reflection? Whoops, I already revealed the answers. But you can see that this is a reflection, but this one over here is not. All right, if we were to draw a line here like a mirror, would it be the same? No, it's not. But over here, would it be the same? Yes, it would be. Okay, so here are the steps to do a reflection. Get these down. Step 1, through each vertex, Draw a line perpendicular to the line of reflection. So vertexes, you'll remember, are these points on any shape where lines meet. We drew perpendicular lines, lines that form right angles. So there's a right angle, there's a right angle, there's a right angle. Okay, step 2, measure the distance from each vertex to the line of reflection. So measure this distance, and measure this distance. Locate the image of each vertex on the opposite side. So this one, if it's 1 away, we'll go 1 more over here. If this one's 4 away, then we'll go 4 over to here. And if this is 2 away, we'll go 2 here. Step 3, connect the images of the vertices. So we connect those dots and we get our reflection. Make sure you jot down all of those steps. Next up is a translation. This is our second transformation. Don't get those two words confused. A translation is a type of transformation. In fact, a translation slides an object a fixed distance in a given direction. The original object and its translation have the same shape, same size, and they face the same direction. It's a direct isometry. You'll remember isometry means that it doesn't change shape or size. Get this down right here. You may not know what it means now, but we'll explain it. Okay, you also need to copy these notes down. This explains a horizontal translation, a vertical translation, and any general translation. What's important is to get these down here. And the image will help you as well. Okay, pause and copy. Okay, a translation is a transformation along a vector. This is a vector, so some sort of line where we've got where we've got an x coordinate and a y coordinate. So the joining a point in its image has the same length as the vector and is parallel to the vector. Okay, that'll make more sense when we look at some examples. So, which ones of these are translations? Okay, this one or this one? Okay, here's your answer. This one is actually a reflection. It reflects down this line right here. This one, though, is a translation. Take the blue figure and we slit it down and over, gives us the red figure. How about here? Which one is a translation? Okay, this one or this one? Hopefully you said A is the translation. It just slides it up and over. This one looks like some sort of a rotation, actually. Okay, and here are some practice problems for you to look at, but I don't want to spend too much time, so you can pause and take a look at what they're doing. All they're doing is saying that we're going to translate it over the vector 3, -1. So that means we take each point and move it over 3 and then down 1, because 3 is our x and -1 is our y. So that's what you see here. We take the x and y, that's the original image, and the new image would be x plus 3, y minus 1. So we added 3, we subtracted 1. And that's what the red is to the blue, over 3, down 1. Okay, same thing here. You can pause and take a look here. Okay, next we're on rotations. A rotation turns a figure through an angle about a fixed point called a center. A positive angle of rotation turns it counterclockwise. Please write that down. In fact, write all of this, but pay attention. Anytime it's a positive rotation, it's going counterclockwise. A negative angle means it's clockwise. Okay, and get all this down here, all of this for each rotation of 90, 180, and 270. I'll explain here. Okay, so again, unless it otherwise says, all rotations are counterclockwise unless they're negative. So let's take a look at some examples. Which ones are rotations, this or this? Well, hopefully you can see that this is a reflection. This would be our line of reflection. This, however, is a rotation. Take the blue figure and rotate it actually 90 degrees. It's a 90-degree rotation. Which one of these is a rotation? Hopefully you can see that this is a translation. We go over and then down. So that's going to be a positive x, negative y. This, though, looks to be another 90-degree rotation. And it is. Okay? If you're going to do a 90-degree rotation, this is the only formula you need. If you're going to do a 180, this is the only formula you need. I think we had those back here, though. So you should already have that down. Our last transformation is a dilation, and this one's the one that's a little different because a dilation is a transformation that produces an image that is not, oh, excuse me, that is the same shape but a different size. It is not an isometry. Okay, so same shape, different size. You'll remember that means it's similar. Get all this down. But this is pretty easy to see when I show you what these this K means. Pause and copy this. Here's some examples. Which one is a dilation? This one or this one? Hopefully you answered B. Okay, these figures are not similar. This one looks like a stretched version of this one. It's not the same shape. However, here, same shape, different size. This one is actually an enlargement. Which ones are these here? Okay, which one is the dilation, A or B? Hopefully you said B. Similar figures, it's just that it got smaller. These aren't even similar. Okay, so in a dilation, we enlarge or reduce. So if it's greater, the dilation is greater than 1, it's an enlargement. If it's less than 1, it's a reduction. If it's just 1, if you're multiplying by 1, what does that mean? Well, it stays the same. It's not a dilation at all. Okay, so these are some examples of dilations. Okay, this figure is a reduction of the bigger figure. And to figure out what the scale factor is, well, measure this here. Here, let me draw it. Measure this, and then measure this. And what's the fraction? Well, it's half. So dilation would be half. We go back here to where we saw K, right here. The K would be 1/2. And so we would just apply 1/2 times X and 1/2 times Y, and we get our dilation. Here's another example you can pause and do. And another one, and another one. Okay? And last, yes, I know I saved it for last. You need to get this table down here. Okay, and this pretty much summarizes everything that we've got. So some of it may be duplicate, but draw a table on your notes, copy this down. Do not print it, Trayvon. All right, this takes us to the very end. So to summarize, we've got 4 different types of transformations. Okay, the first one is a reflection. The second was a translation. We did rotations and last dilations. Okay, and there's specific rules to each one, but hopefully you got the general concept. If you just Google geometry transformations, you'll come up with some cool stuff. Like I found this. This gives you an example of a reflection. Here's another reflection. If you're interested in slides, okay, here's an example of a translation or a slide. Here's another example of a translation. And here's a rotation. So here we rotate, and here we rotate. And there's lots of cool stuff like this online. If you just take the time to research it and do a quick Google search, you might find something that makes more sense to you. Okay? Make sure you bring in your notes tomorrow to school for Geometry's benchmark number 19. Mr. Woolf, signing off.